I'm Anil Kumar. Let me thank all my subscribers and viewers for watching my videos, posting excellent questions, and helping me make this YouTube channel worthwhile. This video is for my student Amna, who wants to understand with examples probability of occurrence of at least one event for independent events. So I've taken up two examples here. Our key issue is to understand the term independent events and at least one of them to be successful. Okay, example number one is consider figure A and B. Switches S1 and S2 have respectively 10% and 20% chances of failure. Find the probability that each of the circuit will work. So let's call this figure as our figure A and this one as our figure B. Now when we say that switches S1 and S2 have respectively 10% and 20% chances of failure, that means for success it is 90 and 80%, and these two are independent switches. Their probability is independent. These events are independent, right? So these switches here, which we'll call S1 and S2. So these are the two switches in both the cases. In the first case, we have put them in series, and in the second case, we have put them in parallel. Now, can you tell me, if we have to find the probability that each of the circuit will work, then out of these, at least one should work means what? Well, in this particular case, both should work, correct? But here, when we place them in parallel, then the case is at least one can work, correct? So when we talk about at least one, you could have examples like we have shown here in figure 2, right? So this is our at least one case. You see that? Either one of them can work and the circuit will light up the lamp. Question number 2. A can solve 90% of the problems, B can solve 80% of the problems, and C can solve 70% of the problems. Determine the probability that we have 4 different conditions. All A, B, and C will solve the problem. That means an odd AND operation. All of them are independent events, right? B. A and B will solve and C will not solve. And C is any two of them will solve the problem. D is the problem is solved. Now, can you tell me which one of these relate to at least one should solve the problem? At least one. So that is option D, right? So when we talk about the problem is solved, then any one of them can solve the problem. It will be solved. So that is at least one case. So at times in our questions, we will find that at least one is not explicitly mentioned, but it is hidden as we have in these two questions. Correct? So I hope that makes sense. And now let us solve these questions and see how we can find probability of occurrence of at least one event for independent events. Here is question number 1. Consider figure A and B. Switches S1 and S2 have respectively 10% and 20% chances of failure. Find the probability that each of the circuit will work. Now in this particular example, as we discussed earlier also, we are given two scenarios. Here the switches are in series and here the switches are in parallel, right? What we are given here is that the switches S1 and S2 have respectively 10% and 20% chances of failure. So chances of failure are given. So let us say our events are failure of 1, right? This is failure of 1. S1, and the chances are 10% for this. And F2 is failure of S2. So what is the probability of failure of the first one? 10%, right? So that means 10 out of 100, which is 1 out of 10. The probability for failure of the second one is 20%. That means 20 out of 100, or 1 out of 5. Correct? So that becomes the probabilities of these two. Now we'll do part B first. Question is, find the probability that each of the circuit will work. Now in this case, even if at least one of them is working, it works. Do you see that? So the concept of at least one is there. When will it not work? When both will not work. Correct? So when we say probability that each circuit will work, so probability of working is 1 minus both fail. Do you understand? 1 minus both fail. That means probability of A, F1 and F2 both happening together. If one of them is working, then you can see that the current will flow. So let's say this fails. In that case, the current can go from this direction. So both have to fail. Then they will not work. So one take away both failure gives us the probability that the circuit will work, or it is a case of at least one independent event is success. Do you see that? Now, since those two events are independent events, we can always write this as 1 minus probability of failure of first times probability of failure of the second one, right? That is equal to 1 minus 1 over 10 times 1 over 5, or 1 minus 1 over 50, which is 49 over 50. If you times it by, if you do a percent of this, you could write this as 98%, right? Times 2. So that is the answer for the first one. Now in this particular case, when we have a situation that both are in series, then either one of them can fail, right? So here the failure is, I should say failure is when S1 fails, or means union S2 fails, right? So when S1 or S2, which I'm saying, any of these switches fail. So that is the probability for this particular case. Any one of them fails. So we could treat this as probability of not failing, right? And so both should be working, or we can say both working. Only then the circuit is going to work. So that means both working is the complement of F1 and F2 as we defined here, right? So in this particular case, probability for working will be equal to both working, that means probability of not failing of the first one, intersection probability of not failing of the second one, not failing. Okay. Now failing is 1 over 10, so we could actually go for, these are independent events, so we could write this as not failing of first one times probability of not failing of the second one, and the probability of not failing is 1 minus 1 over 10, which is 9 over 10, right? So it is 9 over 10 times not failing the second one, it is 4 out of 5, correct? 4 out of 5. Now multiplying them and simplifying gives us the answer. We could simplify this a bit. 5 times 2, right? So that gives us 18 over 25 as the answer, right? So 18 over 25. So multiplying by 4, we get percent. 4 times 8, 32. 3. 4 times 1, 72%. So if they are connected in series, then the probability of their working is 72%. If they are connected in parallel, in that case the probability of their working is 98%, right? Now let's move on and do question number 2. Question number 2. A can solve 90% of the problems, B can solve 80% of the problems, and C can solve 70% of the problems. Determine the probability that there are 4 questions. I'd like you to pause the video, copy these questions, try them out. A. All A, B, and C can solve the problem. Now, A, B, and C are independent events. So all can solve the problems means what? Means their intersection, right? B. A and B will solve and C will not solve. C is any 2 of them will solve, and D is the problem is solved, right? The problem is solved. So these are the 4 parts of the question. I'd like you to answer these questions and then look into my suggestions. Now, A. What we are given here is that the probability that A can solve is 90%. That means 90 over 100 or 9 over 10. Probability that B can solve is 80%. So 80 over 100 or 0, 0 cancel, 4 out of 5. Probability that C can solve is 70%. So it is 7 over 10. Now let us also write probability of not solving the problem, since that will be useful, right? So let me add those things also. So let's write probability that A cannot solve is 1 out of 10. Probability that B cannot solve will be 1 out of 5. 4 out of 5 B can solve. And probability that C cannot solve will be 3 out of 10. Correct? Now, A. All A, B, and C will solve the problem. So that means we are looking for probability of A. We are saying all will solve the problem, right? So that means intersection B and intersection C. That means we have to multiply these 3 probabilities, right? So we get probability of A times probability of B times probability of C as our answer. Is that clear to you, right? Now, you can always calculate this. We have to multiply these 3 to get our solution. Okay? Now, B. A and B will solve, C will not solve. So that means we are looking for the intersection of A and B. They can solve and C will not solve. That is it, right? So that is a minor change which helps us to find the solution. I hope the concept is clear, right? Times probability of C not solving. You have to multiply these 3 now. Any 2 of them can solve. That means we have 3 scenarios, right? First one, we could write that if A cannot solve, but B and C can solve. Is it okay? Plus probability that A can solve, but B cannot solve. Plus probability that A and B can solve, but not C. Right? And we know these are all independent events, so their probabilities are product of their individual probabilities. The last question here is at least one independent, at least one, right? The problem is solved. Now, problem is solved means if I say all cannot solve it, right? So it is 1 minus probability that all cannot solve. Do you see that? So at least one can solve. So that is the case. We could say at least one can solve. So that really means at least one of them can solve. Does it make sense to you, right? So that is the basic for solving questions which are related to independent events and where you may have an option that at least one can solve, right? So I hope that helps. Now let's do our calculations to calculate these answers. So for A, I'm writing this is A, which is probability of A times B times C. That means we are going to multiply these three, which is 9 over 10 times 4 out of 5 times 7 out of 10, right? So, well, there's simple, we could do 2 times 5, and that gives us 200. Okay, that goes 5 times. Okay, so that goes. So we get 9 times 7 as 63 in the numerator, and 25 times 5 is 125 in the denominator, right? So that becomes the answer for A. For B is, if A and B will solve, that means we are going to multiply this time by the probabilities of success for A and B, right? So which is 9 out of 10 times 4 out of 5 times not success for C, 3 out of 10. Is it okay? So that is how you could do it. So 4 goes 5 times here. So again the denominator is 125 and the numerator is 27. For option C, any two of them, so any two of them means we could do A, not A, that means 1 out of 10 times these two, which is 4 out of 5 times 7 out of 10, plus this time we will take 9 out of 10 for A, but B is not able to solve, times 7 out of 10, plus now A and B can solve, that means 9 out of 10 times 4 out of 5 times 3 out of 10, right? So that gives you the solution, right? So what we can do here is quickly add these numerators and then we'll simplify. So denominator, let's keep it constant as equal to 10 times 10, 100, 500. Let's keep it 500, right? And we'll add these things. So we have 4 times 7 plus 9 times 7 plus 9 times 12. 9 times 12 in the numerator, which is 199, right? So we have 199 over 500 as our answer, correct? So that is how we could actually solve this particular question, okay? So I hope it is absolutely clear. Now the last one here is at least one of them can solve. So I could have reframed this saying at least one of them could have solved. So for part D, so this is C, right? So part D, we have 1 minus these three products. So 1 out of 10 times 1 out of 5 times 3 out of 10, correct? So that gives you 3 out of, which is equal to 1 minus 3 out of 500, which is 500 minus 3, which is equal to 497. 497 over 500. Is okay? So that is how you could actually solve this question. So I hope with the help of this video, you understand the concept of what the independent events are. Basically, if the independent events are there, then probability of A intersection B is going to be probability of A times probability of B, right? Secondly, amongst different options, there could be an option like this where we say that the problem is solved. That means at least one of them will solve the problem, and that really means 1 minus none of them will solve the problem. So that is how you could do at least one, and I'll provide you with more links so that you could practice on this topic. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.